Okay, now I want to just do some examples with you here straight out of your assignment so that you can understand it a little bit better. One of the problems I really liked here was on page 338, number 6. If you look at this, it talks about a car dealer going on a sale. It starts out with a starting value of $20,000 for a car. Notice that I put it in a series of blanks here where a sub 0 is this number. A is just a variable. A sub 0, the sub 0 tells me that this is where I start at. So the start value is $20,000. Now this number A is going to change each week. So I call this would be the number A, whatever the value of the car is after 1 week. The value of the car after 2 weeks. The value of the car after 3 weeks. After 4 or 5 weeks. Here it continues on. Now it mentions that he gives a 4% discount every week until this car sells. So a 4% discount implies that 96% of the value remains. So what I like to do is I start with my initial value and then I find out how much remains, and that's what I'm going to multiply by. So I'm going to multiply by 0.96, changing a percent to a decimal. So I'm going to multiply by 0.96 every week here to see what the new price will be, what the reduction is. Remember, that's losing 4% or discounting 4%. So the first question asks us to write what's called a recursive routine. And really, I could accept this as a recursive routine because this recurrence of the 96% is always recurring, or the loss of 4%. A nice way to write that is, though, to write it out, excuse me, as a value here, where we start at 20,000. Then what we do is multiply each term by 1 minus the 4%, which is really 0.96. So then we multiply each term by 0.96 to get the next term. This would be what we'd call a recursive routine. We have to start somewhere. We need a number to start with, and then we do something to that number each time. Here we're multiplying by 0.96 to get each successive term. And here you can see how I did it. So really, either way that you write this would be acceptable. But what we do need is a start, and we need a constant multiplier or whatever changes it. Here in this case, we're talking about exponentials, so it's always going to be multiplying. Here it asks us to find the fifth term. Well, to find the fifth term, I'm going to start with the 20,000 and multiply by 0.96, and that gets me $19,200 excuse me, for that first week. If I want to continue, I'm going to multiply by 0.96 again to get the second week value. Multiply by 0.96 again to get the third week value, and so on until we wind up at the fifth week where I get a value of $16,307.45. And you should be able to round to the nearest penny since that's our smallest amount of money. Another example I wanted to try on the next assignment here on page 345, working with our exponential equation, 3a. Here it says just fill out this table, match it up. So all we do is put in different values for x. X being 0, moving to 1, 2, and 3. We've done this for lines. Now let's do it for the exponential. So it's just y equals 4 times 2 to the 0 power. And one thing you'll find, you could push this in your calculator, but anytime we have a 0 exponent, it's the number 1. So 4 times 1 being 4. To try it for when it's equal to 1, 2 to the first power. Well, to the first power is the number itself, so 4 times 2 would be 8. And here you can see we're multiplying by 2 each time, so the next term I'm predicting is 16. If I make y equals 4 times 2 to the second power, well, everybody here knows that 2 squared is 4, 4 times 4 is 16. So each time our multiplier is times 2, times 2. The next one better be 32. So we could even predict that for 64 multiplying by 2 each time. Where our multiplier is 2, our start value was at 4. And you can make the appropriate match. Nice another problem here, problem number 9, where it's another guy, buying a car problem. Guy buys a used car for $11,500, and it decreases by 20% every year, which means that 80% remains. And this is key because we're always going to use our multiplier to be this b value. Our multiplier is going to be what remains. So if I'm going to put it into this equation right here, a times b to the x, my a value is what we start with. My b value is how much we multiply by each time, what remains. So I can write an equation like this where a is the start of 11,500 and we multiply by 0.8 each time. Here it asks us to find the very first term. Well, I just multiply 80% after 1 year, just one time. This is after 1 year. So I could call this a sub 1. A meaning the value of the car, or maybe I'd have to call it y sub 1 since I've used y here. Sub 1 meaning the first term after the first year. Oh, looks like I used a again. Doesn't matter. A sub 0 to write a recursive routine. To write what's happening here, this is called explicit. This equation here is explicit, meaning we can get right to the 7th year right away. This recursive routine that they ask in B, we start with 11,500, my first term. And maybe I should write y sub 0 or a sub 0. It certainly doesn't matter. The sub 0 is important by being my starting value. Then I'm going to multiply by 0.8 for each successive year. In C, it says create a table showing this value. We just did that, where you can put in 0, put in 1, put in after 2 years, after 3 years, after 4 years, or start with 11,000 on your calculator, multiply by 0.8, multiply by 0.8. Every time that we do, we're multiplying by 0.8. And then we've already written what's called the explicit form. Here, this equation in D. To write a graph, we should notice what's happening here. First of all, be careful. Label your x and y axis. Make sure they're evenly spaced on the x, same spacing on the y. Now, I don't mean x and y have to be the same, but here I'm going up 1 each time, so it better be 1 the whole way. On the x-axis, 1 the whole way. I have time on my x-axis here, value in thousands of dollars on my y-axis. And you should recognize this start of the graph. At the 0 year, at the 1 year it had that value, after 2 years, after 3 years, after 4 years, and you should recognize this type of graph. This is called the exponential, and this is, because it's going down, it's called exponential decay. Get to know this graph. It's a nice little curve, certainly not like that, but a nice even curve that decreases the whole time.